Okay, so and we'll move on to chapter 5, and move on to chapter 5. And so the first unit of chapter 5, this is about like other properties about triangles. So what I want to do is show you this little thing. So here's the idea. You have a triangle. Let's call it ABC. Any triangle, okay? And let's connect it with these sides with segments. Let's say ba 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 ba. Okay. And then the next idea is you're going to find the midpoints of, so let's go back, move. What we want is the midpoints of two sides. So let's see, hold on a second. Where's midpoint? There we go. Find the midpoints segment. Midpoint, midpoint. Okay. The next, so we have the midpoint D, which is the midpoint of AB, and midpoint E, which is the midpoint of BC. And so we're going to make another segment, DE, and the question is, what is the relationship between this segment, DE, and segment AC? There's two relationships. I want you to think about it. Okay, so what do you think? Pause the video. So what do you think? What does it look like? Well, we can use GeoGebra to, you know, inductively test out what we think. It kind of looks like they're parallel, and it kind of looks like DE is half the length of AC. So can we figure that out? Well, we can we can go to like measure the distance or length. So we can click on DE and AC, and we notice, oh, you know what? It is twice. We can move it around. If we move B around, let's move C. Let's see if the number has changed. Yeah, we notice that it's always like twice. For example, let's move. If we make, let's move it to like, yeah, it's like twice. The question is, are they parallel? And so, how do we determine parallel? Well, do we have a thing to determine slope of the line, angle? Let's see, line. No, we can't figure out slope. But what we can do is we can look at the angles. We could do that. Let's see, angle. So that's 3 points. Let's see, B, D, E. Oh, you know what? Let's undo that. So the angle E, D, B. We want to go clockwise, and let's do C, A, B. So it looks like the two lines are parallel. So the question is, how can we prove this? Because we can move. Let's move it back to move. I'm going to move C around, and you see, oh, you know what? D is always parallel to AC, and so it's half length. How do I prove that? Well, I'm going to do it on the board in a second. Okay, so I'm in my room, and because I am in the last week of quarantine, so I can't be in the schoolroom. So I'm doing it in my office, in my house. So we're going to use a different type of proof. We're going to use something called coordinate geometry. So the idea is you're going to put your image on graph paper, and you're going to use what you know how to find, like slope and distance, to prove the idea of that if you connect the midpoints of two sides of a triangle, that segment is parallel to the third side and one half the length of the third side. So what we're going to do is, first, the idea is you have a piece of graph paper, and you're going to plot 3 points, any 3 points, right? And so I'm going to make it a little easier. In a more advanced setting, I would tell you to make this point AB, I would tell you to make this point CD, and I would tell you to make this point EF. Okay? Then you would connect the lines. Okay. The next thing I would ask you to do is find the midpoints. And then you would find the distance between these 2 points. And then you would also find the distance between these 2 midpoints. This is midpoint 1, midpoint 2. So you would find the distance between these midpoints and the distance between A, B, and E, F, which is just the distance formula. And then what you would do is you'd find the slope between M1 and M2 and the slope between A, B, and E, F. And then therefore you'd be able to show that the 2 lines are parallel. Now, first of all, what I tell you, this segment is known as the mid-segment. And so, yeah, that's called the mid-segment. Now, it may seem a little difficult, so what we're going to do is we're going to take that triangle and just put it on, we're going to move it around. Now, so a word that's going to come up in another unit is called an isometry, which means if I take that triangle, can you see it? Yeah. If I take that triangle and like move it around and like rotate it, it doesn't change the area. It doesn't change the lengths. It doesn't change the perimeter. So to make my life a little easier, I'm going to take this triangle and I'm just going to stick it over here. I'm going to put it on the x-axis, and I'm going to make one of those vertices 0, 0. So this point is 0, 0. This point, let's call it A0. And let's call this point random BC. Right? This is going to make our life a lot easier because it's just easier. So what's the midpoint? So let's just quickly prove this in this example. What is the midpoint of 0, 0 in BC? You say, okay, well, it's B over 2, C over 2. And what's the midpoint of BC and A0? Well, this is B plus A over 2, comma, C over 2. Remember, the midpoint is just x1 plus x2 divided by 2, comma, y1 plus y2 over 2. Well, this is easy. So first of all, because they're parallel, it's really easy to find the distances. So if we're starting, let's see, we're starting at 0, and we're going to A. This distance, do I have another colored pen? I do. So the claim is that this distance, the mid-segment here, is 1/2. This is 1/2 the third side. So let's prove that. So if we're starting at B2 and ending at B plus A over 2, the distance is equal to B plus A over 2 minus B over 2. Perfect. And we have A over 2. And then what's distance 2? That's from 0, 0 to A0. Well, this one is A. Nice. The next question is, what's the slope? Well, it's obvious that the slopes are 0, 0. The change in y, the change in x, and then what's the slope? The first slope here is C2 minus C2, that's 0 over A over 2, that's 0. And then the slope here is also there. Therefore, we have proved that the midpoint, we've proven that the mid-segment is 1/2 the third side. 1/2 the third side, and it's parallel to the third side. Now, you can try it up here. It's more advanced. You need more experience with radicals to deal with the distance formula, but if you want to try it out, go right ahead. Once again, make the first point AB, the second point CD, the third point EF. First find the midpoints. keeping all the variables. And then what you're going to do is you're going to find the slope between these 2 points and the slope between these A, D, and E, F. And then you're going to find the distance between M1, M2, and the distance between A, B, and E, F. Once again, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Good luck.